faithfully delivering value by exploring great books worldwide. Hello, this is Sally's Book Talk. Today, we're interpreting the book A Brief History of the Big Bang with the subtitle A Great Contest, where the arena is the universe itself. In human scientific research, there's one ultimate question that's always puzzled everyone. Where did the universe come from? Scientists are split into two factions. One believes the universe is eternal, unchanging since ancient times with no origin to speak of. The other faction believes the universe was created, like a baby being born, and has grown to this day. The two sides have argued for years, neither backing down. Our story unfolds around their debate. In 1949, the top supporter of the eternal universe theory, British astronomer Hoyle, mocked his opponents on BBC Radio, ridiculing the creation theory as nonsense, saying, "So, did our universe just go bang and pop into existence?" They used an English word, Big Bang, not the name of some band, which literally translates to a loud bang. Hoyle meant to tease his opponents in a joking way, but unexpectedly, the term caught on instantly. Originally, the creation faction's formal name was the Dynamic Evolution Model, but from then on, it gained a resounding name. Big Bang, translated into Chinese, is the Big Bang of the universe. This little story is the origin of the term Big Bang. Today, even a science novice has heard of the Big Bang, but few dare to boast about understanding it. This brief history of the Big Bang is perfect for giving you an in-depth science popularization about the Big Bang. The book's author, Simon Singh, is a PhD in particle physics from Cambridge University and a former BBC producer. His books, Fermat's Last Theorem and The Codebook, are not only best-selling science popularizations, but also adapted into BBC documentaries, widely popular. Um, our Sally's Book Talk has also interpreted these two books for everyone. In today's Brief History of the Big Bang, Simon Singh details the story of how two factions of scientists dueled at the peak of the universe's ultimate question, tracing how the Big Bang theory evolved from an unpopular conjecture to being proven and accepted. All right, let's dive into the epic showdown between these two factions. The two sides had 4 rounds of battles, focusing on cosmic redshift, material composition, galaxy distribution, and cosmic microwave background. Let's start with round 1. Back then, there were no cosmic conflicts. The mainstream view was that the universe was peaceful and eternal. Although some scientists deduced from general relativity that the universe was expanding dynamically, it wasn't taken seriously because there was no evidence to back it up. Famous scientist Einstein even tweaked his equations for this, adding a constant to make the universe look static. Even though the theory folks were all in agreement, astronomers found something was off. In the early 20th century, giant telescopes were in use, letting us observe far-off galaxies. But the further we looked, the weirder things got. People were shocked to see that over time, starlight colors changed. Orange turned red, blue turned green, with the whole spectrum shifting red. This is called redshift. According to the Doppler effect, motion causes wavelength changes. Redshift means the light source is moving away from us. On the flip side, blue shift means the light source is coming closer to us. Here's a simple analogy. If the light source is a girl, seeing her dress turn blue means she's rushing into your arms. And when her dress turns red, it means she's walking away. Earth is like an unloved boy. Depressingly, they found almost all galaxies around are like girls in red dresses, moving away from Earth one by one and super fast. Just how unloved. For instance, the Sombrero Galaxy speeds away at nearly 130 hertz, the speed of light. If a plane flew that fast, it would take just 6 seconds to go from London to New York. Research also showed that the real cause of redshift is the expansion of space, stretching the distances between galaxies. This discovery brought an extraordinary consequence. Since the universe is expanding, it must have been smaller in the past. Imagine rewinding time. So, yesterday, these galaxies were closer than today. Last week, closer still. Last month, even closer. We can then infer that at some point in the past, all galaxies were concentrated at a single point, perhaps the universe's birthplace. Now, the Big Bang Theory finally had its first evidence: galaxies receding, universe expanding. The long ignored Big Bang, suddenly no one dared underestimate it. Overnight, it became the hottest topic at academic gatherings. The Belgian cosmologist Lemaitre, who proposed this theory, described it with poetic language. At the beginning of all things, there was a magnificent firework. After the explosion, smoke filled the firmament. However, this emerging theory's path wasn't as beautiful as the poem, instead full of bumps and hardships. Opponents quickly found a fatal flaw in this sole evidence. What happened? Famous astronomer Hubble studied redshift and proposed Hubble's law. It states that dividing a galaxy's recession speed by its distance from Earth gives a constant. And this constant is called the Hubble constant. Thus, the universe's age equals the inverse of Hubble's constant, calculated at 1.8 billion years. And, now they'd caught the Big Bang Theory red-handed. Earth's estimated age was 3.4 billion years, yet the universe's age was only 1.8 billion. This paradox was fatal, like claiming a mother is younger than her daughter. Clearly, redshift alone couldn't support cosmic creation theory, especially since mainstream science viewed the universe as eternal and static. Now, this conservative view regained dominance, and soon the eternal universe theory formed its own faction with a leader. That leader was Hoyle, the one we mentioned earlier, who mocked the Big Bang on BBC, yet accidentally named it. He genuinely despised this theory and led his team to develop a new cosmic model, the steady state model. This model explains the redshift phenomenon while perfectly sidestepping the cosmic age paradox. Let's see how it achieves this. The theory proposes that while the universe is constantly changing, it remains eternally unchanged overall. Sounds contradictory. An example will clarify. A river keeps flowing, yet its basic shape remains unchanged. Cells in our body constantly die and renew, yet we remain ourselves. So does the universe. While expanding, it simultaneously creates new matter to fill the gaps, maintaining constant cosmic density. He argued the universe is infinite. Even after doubling in size, it remains infinite, thus fundamentally unchanged. This is the core of the steady state model. This theory is entirely self-consistent, with an impeccable explanation for redshift. Moreover, since it posits no creation point, there's no age issue whatsoever. From redshift emerged two opposing cosmic views, two rival factions now fully formed. One side, the steady state model, insisting the universe is eternal. We'll call them the eternal fraction, led by Hoyle. The other is the Big Bang model, asserting a cosmic beginning. Its leader is Russian scientist George Gamow. Though not the first to propose the Big Bang, he became its true champion. Both leaders commanded immense scientific respect, equally matched in stature. They clashed publicly with all weapons, Hoyle mocking the Big Bang on BBC, Gamow countering with satirical limericks. Their rivalry became prime public entertainment for a time. Even the Vatican Pope weighed in, endorsing the Big Bang model, claiming cosmic creation offered scientific proof for God's existence. This deeply embarrassed the Big Bang camp. All knew victory required hard scientific evidence. Just both sides entered round two. This time, the core question was explaining cosmic matter's origin. Proving their cosmology meant confronting this unavoidable challenge. Where does matter in the universe come from? Why is there more of some matter? Some matter is scarce. In the universe, the most abundant elements are hydrogen and helium. They occupy the first two positions in the periodic table, the smallest and lightest elements, accounting for 99.9% of all matter in the universe. whereas precious metals like gold and silver, which we earthlings love, are extremely rare. Why did the universe arrange it this way? On this issue, the Eternal faction had no answer. Their explanation was perhaps the universe is unchanging. So the proportions of elements have always been this way. This explanation is too flimsy. At this moment, the Big Bang Theory had its chance to turn the tables. I Leader Gamow proposed this theory. The different elements in the universe originated from nuclear fusion in the Big Bang. Let's explain. First, understand what nuclear fusion is. In nuclear fusion, nucleus refers to the atomic nucleus. Atomic nuclei aren't unchanging. When two smaller nuclei combine to form a larger one, it's called nuclear fusion. Conversely, when a larger nucleus splits into smaller ones, it's nuclear fission. Both fusion and fission are nuclear reactions, the basic principles behind nuclear weapons, with astonishing power. For example, radium, the radioactive element discovered by Madame Curie, undergoes nuclear fission. 1 kilogram of radium can boil a liter of water every 30 minutes, and it can keep doing this for 1,000 years. Atomic bombs are made using fission principles, but fusion is even more powerful. Second-generation atomic bombs, hydrogen bombs, use fusion principles. Their power is dozens or even thousands of times greater than atomic bombs. Why do nuclear reactions have such immense power? The answer lies in Einstein's famous equation, E equals mc squared, meaning energy equals mass times the speed of light squared. The speed of light is 300,000 kilometers per second. This means a tiny bit of mass can be converted into enormous energy. Let's return to the Big Bang. Gamow believed that at the moment of the Big Bang, the temperature reached 4 trillion degrees Celsius. At such high temperatures, nothing existed. The universe was a pot of energy soup. Then space rapidly expanded, and the temperature plummeted. Within fractions of a second, fundamental particles like protons, neutrons, and electrons emerged. Hydrogen also appeared, since a single proton forms a hydrogen nucleus, the simplest elemental structure. 5 minutes later, the universe cooled further. Between trillions and millions of degrees, particles lost the conditions for free existence. Nuclear fusion ignited with lighter elements fusing into heavier ones. Carbon, silicon, iron, the fundamental building blocks of matter were born. They gradually clustered together, eventually forming the galaxies we see today. After publication, this theory caused a sensation, quickly becoming front-page news in American newspapers. The Washington Post ran an article titled, "The World Began in the First 5 Minutes." Observations also showed Gamow's calculated hydrogen-helium ratios matched reality. But just as the Big Bang Theory was riding high, the Eternal faction threw cold water, saying, "You only explained hydrogen and helium, the lightest elements, but not heavier elements synthesis." While hydrogen and helium make up 99.9% of the universe, that remaining 0.1% must still be accounted for. This problem truly stumped Gamow. Gamow believed all elements formed instantly in the Big Bang's first 5 minutes, later proven wrong. While hydrogen and helium measurements matched predictions, the third element, lithium, consistently showed huge discrepancies between theory and observation. Post-Big Bang, temperatures plummeted too fast, halting fusion. Big trouble, over 100 elements on the periodic table, yet only stuck at the third element. How were the subsequent heavy elements created? Now, the Eternal faction revived, with leader Hoyle personally stepping in, finally finding the answer. He proposed elements weren't forged in the Big Bang, but in stars. Specifically, when aging stars exhaust fuel and cool, contraction reignites them. This heating-cooling cycle repeats, creating elements. So a star's death is this endless cycle of burning, cooling, contracting, then repeating the whole process. Hoyle proposed that nuclear reactions happen precisely during this contraction and heating phase because Nuclear reactions require extreme pressure and high temperatures. According to him, stars act like alchemy furnaces, initially taking millions of years to fuse hydrogen into helium. Then, in later life stages, rising temperatures and pressures create heavier elements like silicon and iron. The heavier the element, the later it forms. This explains why precious metals like gold are so rare. Moreover, Hoyle noted that when stars finally die, their explosions scatter these elements across space. These stellar fragments mix with cosmic material, coalescing into new stars and planets, creating the possibility for life. In this sense, every inch of our skin, every strand of hair, once came from cosmic stardust. Humanity, are children of the stars. Well, now we see Gamow and Hoyle jointly solve the puzzle of cosmic matter. Uh, Gamow saw the Big Bang universe as a soup pot, scooping out the lightest elements, hydrogen and helium. Hoyle viewed stars as alchemy furnaces, forging all heavier elements. They seemed evenly matched, but the Big Bang had an edge. Because Hoyle's stellar furnace didn't conflict with the Big Bang, it actually helped explain heavy element formation. Yet, he himself couldn't explain hydrogen and helium's origin. Stars can't produce such vast amounts of hydrogen and helium. Thus, the Big Bang won by fully explaining cosmic matter, a victory built on its rival's work. Uh, this time, Gamow showed deep respect for his opponent. He wrote another limerick praising Hoyle for creating heavy elements even gods couldn't make, honoring his achievement. Let's recap the battle. Round one explained cosmic redshift. The eternal faction held ground, while the Big Bang faced the age paradox. Round two explained cosmic matter composition. The eternal faction couldn't account for hydrogen synthesis, while the Big Bang was flawless throughout. And then both sides had unresolved issues, returning to square one. Yet victory started leaning toward the Big Bang. While these leaders debated matter composition, other astronomers built precise telescopes and made a bombshell discovery. Andromeda's actual distance far exceeded previous estimates. The Andromeda Galaxy is the closest large galaxy to the Milky Way, our reference point for estimating other galactic distances. New observations showed Andromeda was at least twice as far, meaning all other galactic distances must double. Remember how we calculated the universe's age earlier? Time equals distance divided by speed. Double distance means double cosmic age. Thus, the universe's age jumped from 1.8 billion to 3.6 billion years. With astrophotography advances, another galaxy's distance soon doubled again. Yet, we still underestimated cosmic vastness. Data kept refreshing. Finally, cosmic age settled at 10 to 20 billion years, resolving the paradox. The universe was sufficiently ancient. The eternal faction could no longer mock the Big Bang's younger than Earth universe. Now the Big Bang stood firm, fully vindicated. With two issues settled, round three commenced. Both sides focused on galaxy distribution. Their opposing cosmic views led to radically different galaxy distribution predictions. The Big Bang claims young galaxies only exist in the early universe, yet we see them hidden in deep space where light takes billions of years to reach us. Thus, we observe them in their youthful state. Nearby galaxies are mature adults, having evolved as the universe aged. But the Eternal faction believed young galaxies should be evenly distributed. As mentioned, they believed cosmic expansion gaps would generate new matter to fill space, forming new galaxies. So, young galaxies should be evenly distributed throughout the universe. Now, the core question is clear. Are young galaxies only in distant space or evenly spread? Scientists call these young galaxies quasars, quasi-stellar objects, representing early galactic evolution stages. Early on, scientists conducted cosmic surveys with telescopes and actually found quasars. The farther the distance, the more frequent they appeared, nearly all located in the universe's deepest regions. Undoubtedly, this result powerfully supports the Big Bang model while striking a heavy blow to the Eternal faction. After 3 rounds, the Eternal faction clearly lost credibility, yet supporters stubbornly claimed, "We just got unlucky finding no quasars nearby." Hoyle himself rejected the findings, scrambling to gather materials exposing Big Bang flaws. However, their final efforts collapsed in round 4, decisive evidence that sentenced eternal cosmology to death. This ace evidence is called cosmic microwave background radiation. This story traces back to the second round showdown. Back then, the Big Bang theory struggled, unable to resolve the cosmic age paradox or explain heavy element synthesis. Its future bleak. That Gamo's team made a prediction. Remember how the early universe was an energy soup? Actually, besides the soup, fluctuating particles, light, existed. With all particles in chaotic motion, they scattered light, creating an opaque universe. Like fog obscuring cars ahead, cosmic particles acted as dense fog, preventing light penetration. Only when the universe cooled below 3,000 degrees Celsius did this particle fog lift, allowing light to break free and traverse space smoothly. This cooling period took 300,000 years, during which the universe expanded about 1,000-fold. The wavelength of that primordial light stretched 1,000 times too, reaching 1 millimeter in length. This length falls within the microwave spectrum. Gamo's insight. They predicted the universe should be saturated with this microwave radiation, a relic of the Big Bang. Detecting this microwave would prove the Big Bang actually happened. But back then, nobody believed in the Big Bang model, let alone bothered hunting for cosmic microwaves. Gamow spent 5 years trying to convince astronomers, only to face overwhelming indifference. 16 years passed. People had long forgotten this prediction. Then in 1964, 2 American engineers, Penzias and Wilson, set up a horn antenna to receive satellite signals. To test the antenna's noise performance, they pointed it skyward for measurements. They expected decent performance, but the noise during measurements was unbearable. And so they spent a year troubleshooting, scrubbing equipment spotless, even shooing away nearby pigeons. Yet everywhere, anytime, and every sky direction, that mysterious, relentless noise persisted. Just as despair peaked, they stumbled upon Gamo's 16-year-old prophecy, instantly having a divine epiphany. This enigmatic noise was the echo of cosmic birth. It was the Big Bang's cosmic microwave background radiation. Their discovery caused a sensation, earning them the Nobel Prize, with astronomers hailing it as modern astronomy's greatest find in 500 years. And this discovery might feel strangely familiar to you. TV static, snow, radio hiss between stations both carry interference from cosmic microwave background radiation. In those noises, you hear echoes from the universe's infancy over 10 billion years ago. With this, the Big Bang achieved ultimate victory. The Eternal faction once challenged, "If the Big Bang exists, show us its fossil." Let's see it. The cosmic microwave background radiation is the ultimate fossil, irrefutable proof of the Big Bang's existence. By 1980, 69% of astronomers supported the Big Bang, 29% remained neutral, and only 2% steadfastly clung to the eternal theory. Though Hoyle still held his ground, constantly revising his cosmic model. But the tide had turned. The Big Bang became absolute mainstream. Let's revisit the full cosmic creation story. 13.8 billion years ago, space and time began at a single point. After exploding, it rapidly expanded, bathing all particles in an ocean of energy and light. Within minutes, hydrogen and helium were synthesized. 300,000 years later, light first pierced space, leaving cosmic microwaves. Around 1 billion years, the first stars appeared, their nuclear fusion creating diverse elements, enabling future life. This is the story of cosmic birth and evolution. We owe gratitude to all scientists in this epic debate, not just Gamow, but Hoyle too. Hoyle solved heavy element formation. Even Wilson, who discovered the cosmic microwave background, was once a Big Bang skeptic, but their relentless questioning brought humanity closer to cosmic truth. Science is a grand contest, with the universe itself as the arena. In these 3 seconds, while you heard that sentence, the universe expanded quadrillions of cubic light years. Humankind, is this minuscule yet frenzied species measuring cosmic depths with ant like steps in an endless race, never finishing nor quitting. Well, that's the essence of A Brief History of the Big Bang. Reading notes are below the audio. See you tomorrow.